everybody. Today we're going to continue talking about the unit circle and work on some trig functions. So the first thing we're going to do is evaluate these 6 trig functions for the real number 5/4 pi, or 5 pi over 4. You're going to find that we're going to do this a lot from here on out. We're going to evaluate these 6 trig functions. So let's go ahead and list all of them so we have room to answer these. We're going to figure out what the sine value is, the cosine value, the tangent value, and the reciprocal of all these. So the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. And we're going to find all 6 trig functions, and we're going to do this a lot from here on out. Now, the first thing that we might want to do is convert this to degrees. It's not necessary, but some of you are going to be a little more comfortable working with degrees than radians. So let's go ahead and convert just to see what this is in degrees. So if we'll multiply this by 180 over pi, then we can convert to degrees. So cancel out the pi's, multiply 5/4 times 180, and that turns into 225 degrees. So 5/4 pi and 225 degrees represent the same angle on the unit circle. Now if you have your unit circle handy, now would be a good time. You might want to pause the notes and pull your unit circle out, because I'm going to refer to that. So let's go to the unit circle. On your unit circle, find 225 degrees, or 5/4 pi. This is located in quadrant 3. Quadrant 3. This is quadrant 1, 2, 3, and 4. Now, this angle is located right here at this point, and this is your x and your y coordinate. And remember that this is your cosine value, and this is your sine value. So if you'll notice, we already have 2 of the 6 trig values. So let's go back to our notes and let's write those 2 down, because we have those 2. I'm going to write that off to the side here. This is located at negative square root of 2 over 2, negative square root of 2 over 2, which is our cosine and our sine value, our x and our y coordinate. Okay, so here's our cosine value, and here's our sine value. Now I also want to point something else out to you on the unit circle. Let's go back to that. Because we're in quadrant 3, remember your all students take calculus rule, and since we're in quadrant 3, the T means that only the tangent and the cotangent are going to be positive in this quadrant. So as we're going through these 6 trig functions, only the tangent should have a positive answer, and only the cotangent should have a positive answer. All of these others should turn out to be negative. And so far so good, because these 2 are negative. So just kind of keep that in mind and make sure that all of your signs and all of your answers turn out right. Because if you have this on a quiz or a test, this is going to be 6 different answers. And if you screw up 1 or 2 of them, you're likely to mess up on the rest of it. Now if we have the sine and the cosine value, we can also tell the tangent value, because if you remember from your formula sheet, tangent is sine divided by cosine. Right? That equals tangent. So sine divided by cosine, this divided by this turns out to be 1. So your tangent value is 1, and a negative divided by negative is a positive, so it turned out like it was supposed to be a positive. Let's go ahead and do the cotangent. The cotangent is the reciprocal of tangent, so the reciprocal of 1 would be 1. So that one was pretty easy, and those both turned out to be positive. Now, for cosecant and secant, we need to do the reciprocal of these two, and since they're the same, then these two answers are going to be the same. The reciprocal, remember, means you flip these. So the reciprocal of negative square root of 2 over 2 would be 2 over negative square root of 2, or you could put the negative in the numerator, it doesn't really matter. You can't have a square root in the denominator, so you've got to multiply by the square root of 2 to rationalize the denominator. So we have 2 square root of 2 over negative square root of 4, 2 square root of 2 over negative 2. 2's cancel out, and you're left with negative square root of 2. So that would be your cosecant, and that would be your secant. And double check your signs. Make sure that these 4 turned out to be negative like they were supposed to, and make sure that these 2 turned out to be positive like they were supposed to. And you have found all 6 trig functions. And like I said, we'll be doing lots of these from here on out. In this next section, we're talking about the periods of sine, cosine, and tangent. This is going to be useful for a couple of these problems, but we're going to use this a whole lot more coming up later on when we start doing some graphs. But I've already put in the positive and the negatives. This is regarding sine is positive in quadrant 1 and quadrant 2, and it's negative in quadrant 3 and quadrant 4. Same with cosine and tangent. I've already filled in the signs, like positive in this quadrant, negative in this quadrant, negative in this quadrant, positive in this quadrant, based on your all students take calculus rule. Okay, so the signs are already filled in for you. Now what I want to do here is let's take a few minutes and let's figure out some patterns of the plus and minuses for the sine, cosine, and tangent. So we can figure out what the period of these graphs will be. And I say graphs only because I spelled that wrong. Hold on. I say graphs because we're going to be graphing these later, and that's where it's going to be more important. So let's start in quadrant 1, and let's go around the graph in the counterclockwise position, and let's write down plus, plus, minus, minus, plus, plus, minus, minus, and I'm going to put a comma, and let's continue. Let's go around again. Plus, plus, minus, minus. And if you'll notice that I have to go all the way around the circle for this pattern to continue itself. If I continued again, plus, plus, minus, minus, for this pattern to continue itself over and over for the same pattern, I would have to go all the way around the circle, and then all the way around it again, and all the way around it again. And all the way around the unit circle is 2 pi. Because all the way back around gets you back around to 2 pi. So the period of a sine would be, or a sine function would be 2 pi, because it takes you all the way around the circle for this pattern to repeat itself. Alright, let's try cosine and see what happens. Let's start here. Let's go around the circle and see what happens. Start in quadrant 1. Plus, minus, minus, plus. See right there? Plus, minus, minus, plus. Alright, let's go around again. Plus, minus, minus, plus. Plus, minus, minus, plus. Let's go one more time. Plus, minus, minus, plus. Okay, again, for this one, it looks like I have to go all the way around, all the way around, and all the way around for this pattern to continue to repeat itself. So the period for the cosine graph would again be 2 pi, because you have to go all the way around the circle. Now let's see what happens with tangent. Let's start here in quadrant 1, go around, see what happens. I'm going to get a plus, minus, plus, minus. Alright, plus, minus, plus, minus. Alright, let's go again. Plus, minus, plus, minus. And one more time. Plus minus, plus minus. Okay, so by going all the way around the circle, obviously I am getting the same pattern. But if I put commas in here halfway, oh, I put that in the wrong place. If I put commas in here halfway, I'm actually getting the same pattern if I only went halfway around the circle. If I went plus minus, and then plus minus, and then plus minus, and then plus minus. So I really only have to go half the way around the circle for the tangent graph for this pattern to repeat itself. And so half the way around the circle is pi. So for tangent, your period is 1 pi instead of 2 pi. And we'll talk about this a lot more later. It might be a little confusing now. It'll make a little more sense when we start graphing these later. Okay, let's try what we just did to evaluate some cosine or sine, some trig functions. And basically what's happening here is you're evaluating something that has gone around the circle more than one time. So you want to use the period as its aid. So I want to find the cosine of 5 pi. Now all the way here, we're on cosine. All the way around the circle is 2 pi. Alright, 5 pi is more than one time around the circle. So what we want to do is we want to subtract some complete revolutions. We want to subtract a period or 2 or 3, however many we need to, basically to get it back on the original unit circle. Alright, we want to get it back on this original unit circle. So let's take our 5 pi. Since we're doing cosine, we're going to subtract a period here, which is 2 pi. Let's subtract 2 pi, which is a period. And let's see where that leaves us. Well, that leaves us at 3 pi. Well, think about your unit circle. Is 3 pi on your original unit circle? Well, the answer to that would be no, because a complete revolution only goes to 2 pi. So what we need to do then is we need to subtract another period. We need to subtract another period to try to get it back on the main unit circle. So now we end up at pi. Well, is pi on the original unit circle? Hopefully everybody's thinking yes, because here it is right there. Right? There it is right there. That's 180 degrees. Look at the coordinates, -1, 0. I'm going to come back over here. Pi is 180 degrees, or it's located at -1, 0. And remember that this is your cosine and your sine value. Well, we're trying to find cosine, and there it is right there. There's your cosine value. So the cosine of 5 pi equals -1. But what you had to do is you had to subtract a couple of periods, a couple of complete revolutions to get it back on the main original unit circle to find what the cosine value would be. Alright, let's do the same thing for sine of 9/4 pi. Well, 9/4 pi again is more than one complete revolution. So let's subtract a period, which is 2 pi. I need a common denominator. So 9/4 pi minus 8/4 pi turns out to be 1/4 pi, which is pi over 4. Is that on the original unit circle? You betcha, right here. Pi over 4, which is 45 degrees. Alright, look where that is. Square root of 2 over 2, square root of 2 over 2. Okay, so that is, we're finding the sine of pi over 4 equals, well, since they're the same value, square root of 2 over 2, they're both of them, but think about which one's cosine and which one's sine. The first one is cosine, the second one is sine, so it's actually the y-coordinate, the second one, square root of 2 over 2. So it would be square root of 2 over 2. Square root of 2 over 2, square root of 2 over 2, cosine, sine. That one right there. Okay, so it's really, really important that you know your unit circle. We're going to be using it a lot from here on out. If you don't, you're going to find yourself in big, big, big trouble. Okay, we have some trig functions that are odd and some that are even. The only ones that are even are cosine and its reciprocal, which is secant. And I guess the easiest way to remember that is you're going to have the same value whether you're dealing with a positive or negative angle. Okay, you're going to have a same value if you have a positive or negative angle. Okay, for a cosine or for a secant. Any of the others, if your angle changes to a negative, then your sine or your cosecant or your tangent or your cotangent is going to change to a negative answer. I'll try to explain that real briefly, flipping back to our last examples. This is easy to get confused on, but it's really not that difficult. But cosine and secant are the only ones that are even. So like a cosine of 30 degrees and cosine of negative 30 degrees will have the same answer. Okay, so maybe flip back to where we just were and I'll show you what I'm talking about. Alright, let's look at cosine. If you go 30 degrees, you'll be over here in quadrant 1. If you go negative 30 degrees, you're going to be over here in quadrant 4. So for cosine, they're both positive in quadrant 1 and positive in quadrant 4. So a positive 30 degrees and a negative 30 degrees will have the same value, positives, the same number, but they'll both be positive even though you have a positive angle and a negative angle, because cosine is positive in both of these quadrants. Alright, what about like 120 degrees over here? Or negative 120 degrees over here. Notice that cosines are negative. They're both negative. Negative values, even though you have a positive angle and a negative angle. But, like, look at sine and tangent. Okay, 30 degrees here would be a positive. How about negative 30 degrees? See, notice how they're different values? A 30-degree angle would have a positive sign, and a negative 30 degrees would have a negative sign. That's why sine is odd and cosine is even. All right, look at tangent. Positive 30 degrees would have a positive tangent. Negative 30 degrees would have a negative tangent. That's why tangent is odd. So flip back over here. That's why cosine and its reciprocal is even. You'll have the same value even if you have a positive or negative angle. So I don't know if maybe that helps a little bit. Sine and tangent and their reciprocals would be odd. So we have one little example on that one. If tangent of t, and that just means this is a positive angle, is 2/3, find tangent of negative t. Alright, that means it's a negative angle. And cotangent of negative t, negative angle. Alright, if tangent of t, your positive angle, is 2/3, then tangent of your negative angle would be negative 2/3. That's all, because it's odd. And then cotangent of the negative angle would also be negative, and cotangent would be the reciprocal, so you would flip it. And tangent, we're changing the signs because it's odd. But remember, if it was cosine or secant, then you would not have changed these signs. You would have just left them the same that you started with, positive. So just look back at your chart, or just remember that cosine and secant are the only ones that are even. Even. It's supposed to be an E, even. Okay, we're going to finish up here with a couple of calculator things here. Very, very easy, but oh my gosh, people mess up on this all the time. Evaluate using a calculator. Big deal here. Degree mode or radian mode? Here's what I want you to ask yourself all the time. Do you have a degree sign? Look at them. Is there a degree sign there? Absolutely not. If there's no degree sign, go to radian mode. How about this one? There's no pi there. Okay, so what? There's no pi. But do you have a degree symbol? There's no degree sign. So you go to radian mode. Okay? There's no degree sign. So we go to radian mode. No degree sign. So let's go to your calculator. Oops, go to your calculator. Go to your mode first of all. Go down and make sure that you're in radian mode. If you're in degree mode over here, you can punch buttons all day long and every single one of them will be wrong. So you're going to have to be real careful that you're flipping back and forth within the right mode, or you're going to have these wrong. So make sure you're in radian mode. And let's see what we're going to do here. We're going to do sine of 5 pi divided by 7. So all we're going to do is calculate that. Sine of 5 pi divided by 7. And let's do 4 decimal places. So 0.7818. 0.7818. Okay, now for cosecant. Cosecant is the reciprocal of, that blended together there, reciprocal of sine. Here's what a lot of you are going to be tempted to do, because this is what you did in geometry. I'm going to show you on the calculator, but I'm going to write down what you don't do first. You do not do the sine to the -1, the blue button, that you did in geometry. This is for finding angles. We'll use that some more later, but that's not what you do right now. Okay, right here, this sine to the little -1, sine to the blue -1 button, that's not what you use here. That's only for finding angles. So there's 2 ways you can type this in. You can type this in as 1 over sine of 2, or you can type in sine of 2, and then you can take it to the little -1 exponent. So you have 2 options there, but do not use the sine to the -1 button, the little blue button. Okay, let's go type that in. I would do 1 over, because it's 1 divided by sine of 2. Oops. Guess I could do 2 sets of parentheses that way. Okay, that'll work. So 3 decimal places, 1.099, and the 7 would go up to an 8 because of the 5. 1.0998. Now if you want to do it the other way, you would do sine of 2, and then make sure you take that to the -1. You can do this little x to the -1 button like that, and then that'll work. 1.0998. Okay, 1.0998. Okay, so that wraps it up for section 4.2.